Hi, I'm Thomas Wright. I'm a first year electrical engineering student at UVM, and for my final electrical engineering lab project, I designed a motion sensitive light switch that turns on my light when I walk into my room and then turns it back off on a timer or when I change it with some buttons. Over here by my doorway, I have the Arduino set up on top of a ladder on a book, and there's the proximity sensor. So when I walk through my doorway here, it will sense if someone goes through there and will turn on the servo, which flips this down, turning the lights off, and then it can flip it back up, which turns them back on. Over here we have a little display that shows how much time is left on the timer and when the light will be switched back off. And right here there are 3 buttons. These ones on the left and right increase and decrease the amount of time left on the timer if you want to bring it up to 5 minutes or down to 1 minute. And the middle button simply turns the light off and overrides the timer that's been set. The light switch is activated once someone walks within 20 centimeters of the proximity sensor, and then that drives the servo, flipping the light from off to on. When the light switch is off, nothing is illuminated besides the lights on the Arduino board, but when someone walks in front of it, the lights turn on, and as you can see right now it's at the medium stage for the timer. And if I go and I can take away time, so it's 1 minute, add time to get it to 2.5 minutes, add more time for 5 minutes, and then if I press the middle button here, flashes and then flips the light switch back off. Now I'm going to set off the proximity sensor and demonstrate the lowest time setting being 1 minute with a quick time lapse. So now it's on. I'll bring it down to the lowest amount of time and then we'll let it go here. Alright, as you just saw, it flashed the turning off sequence and then flipped the switch back off after 1 minute passed. And it does that same sequence if you bring it up to 2.5 minutes or the 5-minute time interval. If I were to revisit this project in the future, I think that I would actually go into the power mains and actuate the switch with an Arduino powered mains switch. That way I wouldn't have to have the servo running all the time, and it's kind of low quality, so I feel like it might burn out after a while. But I didn't want to have to use my wall power in this project, and I think this is a good, cheap solution. Okay, here's my code for my project. So you can see I imported the servo library for Arduino. Here are all of my pin declarations, variable declarations, and here we have the degrees of the servo position that I will be starting and ending at. Here's the setup, just setting all the pins and starting the serial monitor, which I used for testing. And here's my void loop. It's pretty small because I mostly have all the actual actions that are going on in functions, which are like methods in Arduino. Okay, going through the void loop, the main parts of my program are first setting the servo to its endpoint. Then it's going to check the distance from the sensor to my door and just print that there for debugging. Next, if the distance is less than 20 centimeters, it's going to move the servo up to the start position, so the top of the light switch where it's going to be on. It's going to set timer on to be equal to 1, which is then turning on this loop that keeps checking if the time has run out and if the buttons are changing that. I can't just do a delay because I do want those buttons to be able to change the delay, and delays block out the entire Arduino program, while this later in the code checks how much time has elapsed since this start time, which is set up here. So here we have the move servo function. This just uses the servo library to move the servo the given number of degrees. Down here we have the check door function, which just uses the proximity sensor to check how far away the how much distance there is between the sensor and whatever it's picking up. And here we have the timer function. This does the brunt of the work. It first checks if there's a button being pressed and changes the time based on that. And if there's nothing, then it does not do anything. But then it checks what the difference is from the start time to the current time, and if that's greater than the amount of time that it is pausing for, then it flashes the lights and changes the servo. And then we have the button checker that just reads each of the digital pins and returns a different number based on those. Lastly, we have a simple code or function that takes in a value and based on that displays the certain amount of LEDs, all of them on, only 2 of them on, 1 of them on, and then none of them on. And that's how the code works.